Okay, so we're starting to look at seasonal data now. This is the example which it's figure 9.17 on page 342. And what we're doing is we're trying to build a model of seasonality in gas data. Sorry, not gas stations. So we've got this gas usage data. The original data set has gas and electricity. We're just going to be bothering about gas. And what we want to do is we want to kind of work out if the gas consumption differs across different months. Which, I mean, looking at this data, it obviously does, because it's very high in January, February, and March, but less in like July, August. And I'm also, guessing it kind of, we're not really thinking in terms of change over years, but we're thinking this is going to change from year to year as well, because, different weather in different years, I guess. So we copied it over. Let's just, so I'm not messing around later, just do everything Arial 12. Um, we want to have, if we want to get figure 9.17, we want to have the actual time period, even though we're not using this in the regression. But so I match the book. Just start off with a 1, drag down, and fill series. Now what we're doing is we're doing a regression, and as per the previous chapter, we want to create dummy variables. Now, as I said, if we have, and we want one for each month, but as we noted in the previous chapter, we get linear dependence if we have a dummy variable for every qualitative every qualitative value for month. So we need, if we have k categories, we need k minus 1 dummy variables. So literally, we're going to treat January as the base, and we're going to have every month except January as a dummy variable. The easiest way I want to do this is just select these, Control C, and then go up to paste, paste special, and transpose, and then we get the months February to December. Now, so in the month of January, we don't have any kind of dummy variables set, because that's considered the base case. But February, we'd have February set, March, we'd have March set. Now, to fill this in, I could do count ifs, I could do, and things like that, conditional formatting. But this is it's much easier to just do this manually. So let's just have a 0. And we're going down the first year to December, Control D. And select this, Control R. And starting off February, we have, this is a February dummy variable, March, April, May, June, July, August, September, October, November, December. And then the second year period, we can just copy and paste this, so Control C, Control V. And that's going to be our dummy variable matrix. So now what we're going to do is, again, if I was thinking about this longitudinally as well, I could have a year variable and call this year 1 and year 2. But the book example, as we only have 2 years, we can't really do that. If we have multiple years, we could do that. So let's just build a regression model. So data analysis, regression, and my y variable is the gas usage. My x variable is going to be all of my month dummies. My output range, let's just stick it to the right. So we'll stick the output here. We're just focusing on the regression here. We're not going to spend time doing any residual analysis. So we have the output range. We're not having any of the plots. We've got labels selected because the first row are labels. And click OK. And this gets us a regression model. And we can see the output here. We can see it's a pretty good model. R squared is 0.97, i.e., and we could guess that because we use a lot of fuel in January, February, and we use kind of very little fuel in the summer. Now let's look at this model. And we can see here that pretty much January is the highest fuel consumption month. So it's 237 in January, which is the base mean. And then we subtract 0.5 for February, 0.37 for March, 0.995 in April. Then we have May, June, July, August. And then you see we actually get, by the time we get to December, we get less of a coefficient. And we also then we have a look at our significance and our t-statistics. We see that February is almost identical fuel consumption to March, and it has this kind of, very insignificant t-statistic. So the p-value is 0.98. The p-value is greater than 0.05 for March, but here we're just, it's kind of borderline significant, so we're going to keep it in the model. Remember in the regression chapter, we talked about removing anything with a p-value greater than 0.05. We also had to, if we want to be a bit more conservative, remove anything with a t-statistic. The absolute value is less than 1. So let's just do that. Let's just right now rebuild the model without February. And we don't have to rearrange our data. While we're here, let's just make it look a bit nicer. So let's just do the regression again. And this time, what happened there? Data analysis, regression. This time, before we were D to N, now I'm just gonna do this manually from E to N. So we're basically getting rid of February. And our second regression model, I'll just keep at the top. I'll put it up here, Z1. Okay. And just make it consistent. And you see here, let's just see if the adjusted R squared has increased. So you can see, because we removed the pretty much useless variable, the adjusted, even though the R squared has declined, pretty much hasn't changed. We've got the adjusted R squared has gone up with this. And you can see now that, in fact, March is now less than 0.05, which again is kind of why you don't want to be really strict when you're removing variables from regression models, because if you may remove a useful variable. So we see here, this is our final thing. So in January, we have an average of 236 kind of heating units. We have 200 exactly for March, approximately 136 for April. Again, we just subtract each of these values from the intercept. May, around 40, around 35, just under 30, and then we start going back up to December. So this is kind of just a way of modeling seasonality and modeling. I mean, in a way, you could probably do this with averages in a pivot table, but it just shows how the differences in fuel consumption per month and calculating seasonal variables. Okay, and I think that's pretty much it.